Okay, let me make some other videos on 11.3s. I'm going to break these into smaller pieces. I had to move home because they're kicking us out of school. First I'm going to talk about an error, then I'll talk about error bounds. So we have a series. What's a series? So it's a summation, little n equals 1 to infinity of a sequence, an. Now I'm going to make a definition. This is my definition. If I don't see this in books, I'm going to go and call that S infinity. Okay. Now, when we go to do a series, suppose this guy converges, so it goes to some number. But we can't go out to infinity, so I got to say use 50 terms to approximate this guy. But like I've been telling you all year, you can't do an approximation. Can't give your boss an approximation that says, here's the answer. It's just approximation unless you tell your boss how good it is. What's your error bound on this approximation? So say we went out 50 terms, so we would use S50. How much did we screw up by? We screwed up by what's left over. The summation n equals, we stopped at 50, that's a 0. We stopped at 50, so we start at 51 and go out to infinity of a, and that's the pieces we didn't use. This is what we used for our approximation. This is everything we threw away. So we'll call this thing right here our remainder. That's the stuff that's left over, and this is S50. So let's look and see what we would do. So in this guy, if we got Sn, what's Sn equal to? That's summation little n equals big N to, no it doesn't, equals 1 to big N of An, okay? Now, and then what's this guy going to be? Your remainder term is going to equal, and this is what always screwed me up, little n starts where? Does it start at n? No, it's where you left off. You quit at n. So it's going to start at n plus 1 to infinity of an. Okay, so let's rewrite this and get this down our heads, and I'm stop it, and we'll do a next video on error bounds, how we're going to use the integral test to help us with this guy. Okay, so put it all together. S infinity, which is the series, is equal to Sn plus Rn. Well, what's Sn? This is this guy right here. That is A1 plus A2 plus A3 plus ... out to a big N, and that's this guy. And then plus all the rest of it, a n plus 1 plus a n plus 2 plus ... out forever. That's this piece. So Sn, which you already know, is a summation n equals 1 to n of an, and Rn is equal to summation little n equals this number plus 1 to infinity of an. Okay, stop the video there.